Learner's Note is an online solution to encourage better way of education to students. I'm Aishwarya and I will be a mathematics teacher for the day. So let's go directly into the topic. So today we're going to deal with areas of parallelograms, trapezium and rhombus. So first let us go into area of parallelogram. So area of a parallelogram. Now before going into area of a parallelogram, let me ask you, what is a parallelogram for that matter? So I hope that you guys would have learned about what is a quadrilaterals, because you might be familiar from a parallelogram from the word quadrilateral, right? So this word quadrilateral has got lots of importance for parallelogram. What is quadrilateral? Quadrilateral is any closed polygon with 4 sides, right? And so parallelogram is also a kind of quadrilateral which has like opposite sides equal to each other, at the same time they are parallel. So I have a picture here for you. So ABCD is a parallelogram. So you can see that BC and AD, they are the opposite side, they are equal to each other. And also we have AB and CD, they are also equal to each other, they are opposite, they are parallel. So you can see that this is something which is called as a parallelogram, which are parallel sides opposite to each other and they are also equal to each other. That's called as a parallelogram. So now let's just figure out how do we get the area of a parallelogram. So just bluntly, if I can tell you, like, the area of a parallelogram is just like base into height. But I have a little bit of an experimental setup for you guys. Find the area of a parallelogram. Now if I tell you directly, area of a parallelogram is just blankly base into height. But I can give you like more of an interesting way to find the area of a parallelogram. So I have like a kind of setup right here, which is like shown to you. So we have a parallelogram and I'm telling you that the base here, right here, is called as B. That is nothing but the base of the parallelogram, and this that is here, right here, this is called as the height. So you know that a parallelogram is going to have a base and a height. So this is the base and this is right here, the height. Okay, so what we have to do next is we have to cut this parallelogram, like a small portion has to be cut, and the demarcation that is given is here. I hope you guys can see this. So we have to cut that parallelogram like along its edge, like along its height, like this. And when you cut it, what's going to happen is we get something like this, and this piece just gets separated, right? Now if we just take this piece and we arrange it in such a way that you get a rectangle right here. So what we have to do is take this piece, bring it to this side and just flip it over, you get something. So this is that missing piece, like we cut this piece and this is the missing piece on this side. So you can see that here. See? So what happened? So here this was the height, right? This whole thing was the height. That right now it became like this height, that's the base, and you have the length there. So this is becoming a rectangle. So did you understand how we transformed an entire parallelogram into a rectangle? So what's the area of a rectangle? So area of a rectangle is nothing but length into breadth, right? So you have L here and you have B here. So the area of a rectangle is equal to length into breadth, which is the area of the parallelogram. So that's how we simply like find out the area of a parallelogram using like this small experiment. So can we just go into a more physical method of experiment and I can show you out. So let's directly move into a physical experiment. Okay, so I have a parallelogram right here for you guys. So look at this. This is directly forming a parallelogram, right? Exactly, this is a parallelogram. Now we need to find the area of this parallelogram. So how do we do? So normally we will multiply, this is the base and this is the height, we'll multiply, right? But I have a very interesting like technique for you. What I'm going to do is I'm going to cut this parallelogram right along its height. So we have the height here. So I'm going to cut this directly. So yeah. So I have cut it. So what I'm going to do, I'm going to arrange in such a way that I'm going to take this cut piece of the parallelogram which I cut along its height and join it like this. So can anyone just tell me what just got formed, like what shape just got like formed right now? See, it's nothing but a rectangle. So a parallelogram got transformed into a rectangle like this. So how interesting that is, right? So now we just need to find the area of a rectangle, and area of a rectangle is very simple, that's length into breadth. So we have the L here and we have the breadth here. You just need to multiply length and breadth. So that's how simple it is to find the area of a parallelogram. So I have an equation here made for you, like this even experiment is important, but at the same time you should be knowing like what are these formulas, right? So you know that base into height is the area of a parallelogram. So base into height is the area of a parallelogram. But when we did the experiment, we saw it transformed into a rectangle, which is nothing but area of a parallelogram is same as that of area of a rectangle itself. That is nothing but length into breadth of the rectangle. So that is all about the area of a parallelogram, which is equivalent to area of a rectangle. That's equal to length into breadth. So now we are going to find the area of a trapezium. So before going into area of a trapezium, let me introduce to you what is basically a trapezium. Now trapezium is also nothing but a quadrilateral which has got like 4 sides. So you can say it's a closed polygon which has got like 4 sides. But what is the difference between like a quadrilateral and a trapezium? So the only difference between a quadrilateral and a trapezium is that in a trapezium we have got only one pair of parallel sides. Exactly, only one pair of parallel sides. In parallelogram, when we discussed, there were 2 equal and opposite pair of parallel sides. But in a trapezium, we have got only one pair of parallel sides. So here we have the base, this is the base, and this is the another base basically. So there are 2 bases. So these 2 bases are basically parallel to each other. So there's only one set, and if you consider these 2 opposite sides, they are not parallel and they are not equal. So we just have only one pair of parallel side in a trapezium, and we are going to find the area of a trapezium next. So I will show you the area of a trapezium using an experiment. Okay, so look here. So we have got a trapezium. Okay, so I'm just going to show you like only one trapezium right here. Okay, so this is like a right angle trapezium where you have one angle right here is 90 degree, and you have the base right here. This is base, these are the 2 bases. Now just imagine that I'm considering a same exact trapezium as this. So this is again a same trapezium as this, like it's exactly a same trapezium. You can see this, both are same. Now you might have wondered like why did I take 2 trapeziums, right? I can show you. So what I'm going to do is the same trapezium, I have the second one, I'm going to invert it. So what do you mean by like I invert it? So I'm going to just invert it like this, and I'm going to join them together like this. So what is the shape that we got right now? It is nothing but a parallelogram, right? See how interesting it is that we got from an entire trapezium, using 2 trapezium, we formed a parallelogram. Now you might be wondering what will be the area of this trapezium, right? So how do you find the area of this trapezium? It's nothing but you have to find the area of this entire parallelogram, and it will be just half of it, because 2 trapeziums are forming one parallelogram, right? So there are 2 trapeziums like this, and when they form together you get one parallelogram. So if you find the area of this entire parallelogram, you just get the half of it, and that half area would become the area of just one trapezium right here. Okay, so hope that's clear for you. So I can show you that using maybe an equation. So yeah, so the same thing which I just showed you is being like pictured here. So there are 2 trapeziums, one trapezium itself, and that one trapezium is being like inverted, and we got a parallelogram as a whole. One thing I want to say you is that for the trapezium 1, or the first trapezium that we took, has got B1 as its base and B2 as its another base. So B1 and B2 are 2 bases. Now when you flip it over, like when this becomes like a mirror image and you join them together, what happens? This B2 goes on top and B1 will come at the below, and it forms a parallelogram, right? And what is the area of a parallelogram? Area of a parallelogram is just nothing but base into height, right? So area of a parallelogram is just base into height, and here in the new parallelogram that we got, what is the base? It's nothing but B2 and B1, which is nothing but B1 plus B2, as simple as that. So our complete base will become B1 plus B2. So B1 plus B2 into height. Now what did I tell you? What is the area of a trapezium? It's just half the area of a parallelogram. So that's why I've put half into B1 plus B2 into height. So it's just nothing but the area of a trapezium is half the area of a parallelogram. So hope that's clear for you. And now we can move to the next interesting shape, that is the area of a rhombus. Okay. So let's understand what's the area of a rhombus. Now before going into the area of a rhombus, let me give you an idea of what a rhombus is. Again, rhombus is a quadrilateral, and quadrilateral has got 4 sides. The same thing goes with a rhombus itself. It has got 4 sides, which are basically it's a closed polygon. But what's the difference between a rhombus and a quadrilateral and a parallelogram? So rhombus is a special type of parallelogram in which all 4 sides are equal. Yes, it has got 4 sides, but the great thing is that all 4 sides, 1, 2, 3, 4, all 4 sides, they are equal to each other. So that's why I've written rhombus is a special type of parallelogram whose all sides are equal. So that's the only thing about rhombus, that it's a parallelogram where all the sides are equal. Okay. So now let us find out what's the area of a rhombus using an experiment. So now let us understand what is the area of a rhombus using an experiment. Okay, so this experimental setup for finding the area of a rhombus is nothing but, what I'm going to do is I'm going to inscribe a rhombus inside a rectangle. So what I'm going to do, so I'm going to make a rhombus here. So this is a rhombus, fine. So I hope that it's a rhombus, so now what I'm going to do is I'm going to take a rectangle and I'm going to inscribe this rhombus inside a rectangle. So I'm going to do, you can see here, and we have this and this. So you can see that the blue, what we have inside is a rhombus, isn't it? So what I've done is, there is a rectangle, and inside the rectangle I have inscribed a rhombus. Now you will ask me, how do we find the area of this rhombus, right? So I'll tell you that we have rectangle, and the rectangle has got dimensions. So this dimension is basically considered to be your length or breadth. So I'm going to take this area or this length as D1 and this breadth as D2. So can you see that the same thing is there for a rhombus itself, that is this, okay, this, that means this is nothing but D2, that is a diagonal of a rhombus, and this, that is the length of the rectangle, which is considered as D1, is nothing but another diagonal, that is nothing but D1. So it becomes like a D1 becomes one dimension of a rectangle, and D2 becomes another dimension of this same rectangle itself. So how do we find the area of this? Area of this rhombus is nothing but half the area of this entire rectangle, because the reason is, you can see that each these squares, like they're small, and they all 4 is inscribed in the same, and they're centered, and each of them is like half of other. So this is completely making up one square, and if you make these together, that will also make one square. So this is exactly half the area of the entire rectangle. So if you find the area of the entire rectangle and half it, you get the area of the rhombus. So that was the setup. See, the same thing I just showed you. You have the rectangle, that is rectangle EHGF, and we have the rhombus ABCD. You have the center of the rhombus, that is O, and we have got the diagonals D1 and D2. So how do we find the area? It's half the area of the rectangle. That's nothing but half the area of D1 and D2. So we have the equation right here. So area of a rhombus is equal to half the area of a rectangle. What's the area of a rectangle? It's very simple. That's nothing but length into breadth. So D1 into D2 is the area of a rectangle, right? So D1 into D2, and half the area of the D1 into D2, you will get area of a rhombus. So half the area of rectangle is equal to half into D1 into D2. So that's equal to nothing but half into product of its diagonal. How does it become product of its diagonal? Because D1 and D2, they are becoming the diagonals of a rhombus. So D1 and D2 are the diagonals, which are not equal, by the way. They are of different lengths. So half into D1 into D2, or basically half into product of the diagonals, is nothing but the area of a rhombus. So that's it about the area of a rhombus. So let us have a recap of what all we just studied today. So we studied about areas of parallelogram, trapezium and rhombus. So what was the area of a parallelogram? You know that area of a parallelogram is equal to base into height. But experimentally, how did we find out? It was nothing but we dissected a parallelogram along its height, and we joined along its same height on the other side, which became a rectangle. And what is the area of a rectangle? It is nothing but length into breadth. It's nothing but the same thing. It's a parallelogram or rectangle. It's the same thing. So the area of a parallelogram is same as that of area of a rectangle, that is equal to length into breadth. Then we can move on to what was that? That is nothing but the trapezium. So what was the area of a trapezium? So area of a trapezium is nothing but we had like a single trapezium which was like right angled. We took the same trapezium, we flipped it over and we joined them together. What did we get? We got a parallelogram. So we know that area of a parallelogram is base into height. So here this time we have got like two bases, B1 and B2. So if we find half the area of the parallelogram, that is going to be the area of our trapezium. So area of a trapezium is equal to half into B1 plus B2 into height, where B1 and B2 are the two bases of the two trapeziums that we took, or B1 plus B2 is the complete base of the new parallelogram that is formed. Then we had the area of a rhombus. What was the area of a rhombus? What did we do for it? So we took a rhombus, we inscribed it inside a rectangle, right? And we considered that the rectangle's length and breadth was D1 and D2, which is same as that of the diagonals, two diagonals of the rhombus itself. So area of a rhombus is nothing but half the area of D1 and D2, right? Because D1 into D2 is going to be the area of the entire rectangle. So if you half it, that is D1 into D2 divided by 2, or half into D1 by D2, you're going to get the area of a rhombus. So finally, area of a rhombus is equal to half into D1 into D2, and where D1 and D2 are nothing but the diagonals of the rhombus, or which is equal to half into product of its diagonals, which is the area of a rhombus. Learner's Note believes in learning concepts by learn by doing methods. So if you want to know more about us, please visit our website www.learnersnote.com. So I'm Aishwarya, your mathematics teacher, signing off. Have a great day.